In this video, we're going to learn about a method called the shell method for finding the volume of a rotation. So again, they're going to give you a set of equations that are going to define a shape in the plane, and then they're going to rotate it around something. So in this case, we have the graph y equal to x squared. Looks something like this. Then we're going to have y equal to 0. Looks something like that. And then finally we have x equal to 4. And so this is our shape that we are dealing with here. I'm going to go ahead and erase the extra parts. And so now we're going to rotate that shape around the y-axis. So when I rotate this around the y-axis, it's going to look something like this. And I do struggle with drawing these three-dimensional shapes. It's like an empty cylinder, but instead of the opening being the complete circle inside, it kind of tapers off into the middle. So this is our shape here. Now, we're not going to use the disc washer method from before because we're rotating around the y-axis. If I wanted to do the disc washer method, then I would need to break up things into little pieces like so in order to get my washer there. And once I did that, now my thickness of my washer is dy, and I would need to turn my whole problem into terms of y and integrate over y. But instead, there's a method we can do it while leaving everything in terms of x. So let me draw my shape here again. Looks something like this. I'm not trying to be too accurate on my picture here. So what we're going to do is we're going to keep breaking up things in terms of x here, and we're going to have a little dx part. But what we're going to do is we're going to take this and shift that little piece around. So what ends up happening is, since the thickness of this is dx, as you're going around there, it's going to be a cylinder, but it's going to be a cylinder with essentially no thickness to it. So the thickness to the cylinder is just going to be dx here. And we call this a shell. It's essentially the outside shell of that cylinder. One thing that you can kind of think about that would be something like this is think of the soup cans and think of the label on the soup can. If you just had that label in that shape, where the thickness of that label is so thin it's not even really registering there, that would be the shell around the outside of the cylinder. That's what we're talking about here. So this piece of this shape is this shell that goes around. So what is the small little volume of this shape? Well, for a cylinder, really it's the surface area around here we're looking at. So a surface area of a cylinder is 2 pi RH. That's the formula. Again, you may memorize it, maybe you didn't memorize it, it's fine, but the surface area of a cylinder is 2 pi RH. That's going around here. And then once we have that, we're going to multiply it by the dx, the width of it, and integrate it. So let's see how we're going to handle this. So we're going to integral here. My x starts at the beginning of the original shape, which was 0, going up to the last x in the original shape, 4. We're going to have our 2 pi here. Now we need to figure our radius. Well, the thing is, our radius, in this picture right here, it's how far away you are from where you're rotating around to the edge of your current shape. So since I'm rotating at the y-axis, I want to see how far away I am to this point. Well, that's just going to be whatever the x-coordinate of that point is. So my r in this case is just going to be x. Now my height is how high this shape is going to be. And in my picture over here, that height is just going to be the height of my function I was given, which is x squared. And then again, we multiply it by the thickness dx here. And this is the integral we're going to have for the shell method. So this would work it out to be, let's see, it's x cubed there. So integrate that. going to be x to the fourth over 4 from 0 to 4. 1, 4 cancels, and you get 4 times 4 times 4 is 64 times 2 is 128 pi. So this would be the volume of that original shape, taking it, rotating around the y-axis. Myself, I pretty much just use shell method when I'm rotating around a vertical line like the y-axis. If I'm rotating around a horizontal line, I would generally choose in order to use the disk or washer method from the previous video. But this works as well here. The second one's just a small variation here. We start by doing y equal to x squared and y equal to x. And this is going to be a little hard to draw. I should have maybe changed the numbers here so it's easier. So y equal to x looks something like this. Y equal to x squared looks something like this. Again, this is not super accurate. So at the end of the day, let me go ahead and make this look better. It's going to be something like this. And that's the starting shape, which we're going to rotate around the y-axis again. So as our formula here, right, it's the integral a to b 2 pi rh dx. My radius, again, is the distance from where you're rotating around to a random point on the shape. And if you're rotating around the y-axis, your r is always going to be x here. So if you rotate about the y-axis, r is always going to be x. Now they can throw other ones in there, but for us, this is all I'm going to make you do is around the y-axis here. Now the height, in this case, since we have two different functions, and if I kind of blow it up here, right, we had y equal to x on top and y equals x squared in the bottom. So the height is going to be the difference between them, x minus x squared. That's our h there, throw in our dx. You can solve for where they intersect each other. It's going to be 0 and 1 again. Distribute the x in, x squared minus x cubed. Do our integrals here. It's going to be 1/3 x cubed minus 1/4 x to the fourth. Plugging in 1 here, 1/3 minus 1/4. Plugging in 0. 1/3 minus 1/4 is 1/12 times pi. 2 pi is pi over 6. And that gets our answer there. So you see the method of shells, in my opinion, is primarily for when you're rotating around a vertical axis. You can, however, use it around a horizontal axis. You can use it a lot of other ways. But I think this is the way that kind of works out best. So as an overview up here, if you rotate around x-axis, I would recommend using the disk washer method, and if you rotate around the y-axis, I'd recommend the shell. And the reason why is both of these let you do everything in terms of x, whereas if you did the opposite of them, for example, you use shell method around the x-axis, you'd have to do everything in terms of y. My personal preference on these.